How about reducing EMC, EMI testing time and complexity and avoiding unnecessary costs with an affordable solution? To help with that, Tektronix just released an all-in-one, easy-to-set-up pre-compliance and debug solution compliant with CISPR and MIL standards called EMCVU. Engineers and technicians said setting up the spectrum analyzer to do EMI is not easy. So Tektronix created an easy-to-learn wizard for pre-compliance with built-in getting started steps to guide users in the process of setting up the spectrum analyzer with accessories for EMI pre-compliance. The application supports both radiated and conducted pre-compliance test setup. Users can either configure their own accessories or choose the ones Tektronix have pre-selected and validated for them. In the case of performing radiated tests, two types of antennae are needed. The application provides a chart showing the impact of the accessories' losses or gains. These are taken into account during the rest of the measurement. If users choose their own antennae or accessories, they can enter their contributing loss or gain as either constant loss, loss table, or also antenna factor. These values are taken into account during the measurements. Also, these tables can be saved as .csv files for reuse. The wizard also provides a number of built-in emission limit lines for CISPR-based standards. Here is an example of all the tables supported from the EN 55011 standard document. We support other EN standards, FCC, and MILGov standards. You can preview the limit lines and the margin before starting the measurement. In regard to the measurement, you have the choice of three measurement approaches. You can accelerate the CISPR-based measurement by deciding on what failure you want to apply the time-consuming quasi-peak detector by selecting pre-scan plus manual spot on failures. You can also choose to have it automatically on the number of failures or do a complete scan with the detector of your choice. This wizard also includes a configurable reporting tool. You can enter user environment and device under test information. Later, this video shows notes and pictures can be captured for each experiment. Once all the settings of the wizard are in place, you can select Setup Complete Run Test. Then your spectrum analyzer is configured and the measurement is initiated. We have selected a pre-scan in peak followed by manual measurement in quasi-peak. The results of the pre-scan show a number of signals in the results section of the display. In red are the signals failing the limit, and in orange is the signal failing the margin. Other signals within the threshold and excursion are noted in blue. We have a failure at 48 MHz after a CISPR peak scan. This FCC limit is built out of 4 ranges of frequency, so we are zooming in the first range where the failure occurred. We are now measuring this failure in quasi-peak. The results is shown as a green dot on the screen, and the actual measurement is added in the results section. The frequency still fails even in quasi-peak. We're going to see if this failure may be a false issue and run an ambient trace. You leave everything in place on your setup except for turning off the device under test. The purple trace represents the ambient noise. In the emission results, you see the measurement of the ambient noise at 48 MHz. It shows the failure is actually not coming from the ambient noise, but from the device under test. In the control panel, you can freeze the trace on the screen and, more importantly, save the trace in a file of your choice. We are going to show some new debug tools Tektronix offers to analyze failures. This particular tool is called Inspect. This tool allows you to bypass scans or pre-scans. You can select the frequency of interest or the harmonics of a fundamental frequency you want to analyze. With this tool, you can make measurements at the resolution bandwidth stated by the standard, or you can change that. In addition, you can define up to 3 detectors for the measurements and 3 different limit levels. You can also state the dwell time you want to use for this particular measurement, or just use auto mode. All these measurements can be done once or over several acquisitions or scans. Results highlight the failures in red and provide a delta to the comparison level chosen. Another debug tool is called level target, similar to what other vendors call display line. This operates like an horizontal cursor that indicates the energy level to target as you debug an issue. Spectrum display opens and you can see how the line level is the same in both EMC, EMI display and Spectrum display. This line is also available in the persistence display we call DPX Spectrum. This display gives you real-time acquisition and helps you to see intermittent signals as well as signals hidden over signals such as broadband noise. As we are debugging this 48 MHz signal, we want to see whether harmonics of this signal or subharmonics are also prominent. To help with that, we are now offering the capability to link our markers so that they are placed at harmonic frequencies of a fundamental frequency. In this case, we select 48 MHz as our fundamental, and we place markers at half, second, third, and fourth harmonic. The actual readings can be seen in the marker readout table on the right side. Lastly, this application includes a configurable reporting tool. Users will need to choose a title to name their experiment, then they can capture notes regarding that experiment. They can also add images of the test setup, including analysis control setting, as well as the measurements results, including the inspects results are pre-selected for you. The published report contains as many experiments as you choose to include. User, environment, and EUT information will also be included. When you generate the report, you will see several sections that correspond to the test setup and the different experiments you opted to report on. Accessory loss table and graphs with legends are also captured. The report can be saved as PDF file or multiple other formats, including RTF file. These new features added to SignalView PC can be enabled via either a node log or a floating license. This can be purchased as separate line items or, as shown in this slide, or the node log can also be purchased as an option of our Tektronix USB spectrum analyzer. The features are also available on the RSA 5100B when option 32 is purchased. For more information, please take a look at our website or contact your local representative. This concludes this video about how Tektronix can help you reduce EMC EMI testing time and complexity and avoid unnecessary costs with an affordable solution.